recording. I think we are on now. All right. Welcome. Chapter 5. All right. Modeling domain behaviors. Modeling complex behaviors as pipelines, letting data guide the design, making illegal behaviors impossible to represent. We are going to leave the cozy and safe world of oil curing and checklists and jump head first into the messy, frantic world of software development. No more isolated modeling. We're going to take the data oriented tools we've learned and apply them to building a complete feature. Okay, so I just start from chapter 5 of the same book. Just finished chapter 4. All right. Yeah. So this means dealing with everything that makes software development hard: database, frameworks, services, and worst of all, existing legacy decisions. Everything in this chapter will be done inside of an existing application. One will make up as we go. Okay. We are going to learn how to carve out a world built on data inside of an existing one built on mutations and identity objects. So if you recall, identity objects are objects that basically mutate, right? Like you can change them as they go, but a value is a value. That's the whole point of the book. The number one does not change. If I do 1 plus 1, I get a new number 2, but 1 still exists. But with identity objects or mutation, 1 can become something else. So if you create a class of boys and then you mutate it into a class of girls, that's acceptable, right? But it shouldn't be. Like, we should have a final class boy and a final class girl, and none of them to intertwine, or not intertwine, but mutate. If you get a boy object, it should remain a boy object as far as we go through like development, right? This chapter will be challenging. uh, the features the feature we're going to implement is non-trivial and built from complex requirements. At the end of this, you will be battle hardened and have all the tools needed to tackle any feature in your own application. Let's get started. Is that how you say that? Let's get started. Encouraging timely payments. We're going to explore the spiritually fulfilling world of invoice processing and and charging late fees, or as it's known in the corporate speak, implementing systems which encourage timely payments. Customers aren't paying their bills on time, and the accountants can't keep up. So we're going to automate the process. In the previous chapters, we walked through the process of gathering requirements in details. Um, it remains the most important step, but we'll pretend we have already we already did it so we can focus on the implementation side. Here, here is what we've got as a set of formal-ish requirements. So one, you have the requirement ID A1, the system. Well, let me just, whatever. I'll just leave it here for a moment. Don't have to read through this. Do I? There's gonna be a waste of time in it. Maybe I'll just link this somewhere in the description if you need it, right? I'll just scroll to it. Or maybe let's read G2. The system shall record a rationale or whatever they call it for invoices which cannot be billed. So what is the reason why you can't bill it? The system shall record which invoices were involved in the fee computation. Okay, summed up in plain English, we find all the invoices for customers that are past due, add up their outstanding balances, then cut a new invoice with a fee that's a percentage of that total past due. Easy. That's a mouthful, man. The hairy parts are in the details. Due dates have all kinds of special rules and exceptions, and half of the requirements deal with figuring out if this fee can even be sent to the customer or sent to customers. There's a narrow Goldilocks zone, too small and we skip it, too large and it needs manual approval. On top of all that, every decision made to be needs to be auditable, so our fees need persisted whether we build them or not. To further complicate things, we're going to embed this feature into an existing application that's already steeped in design choices we did not get to pick, or maybe picked ourselves, but now slightly grown at the we grown at it in hindsight. There's already a database, a very opinionated framework like Spring Boot, Josh Long, Bootyful, an ORM, or whatever magical annotated based mapper, and a host of service integration with APIs we don't control. Our service is a small cog in a large sea of other not so microservices. So we have all this. So we have customer, fee processing is here. We have a billing. We have contract service, rating service, and approval service. We own we own who should be charged, how much, why, and where, and when. It's a lot to take in, and it's going to take a bit of setting the stage. But this complexity let us see how data orientation fits into the real world system. Despite this jump in complexity, we'll stick with the same strategy we've used so far. Focus on the data. Focus on that. All right. Invoices are documents that say how much customers owe for the services they've used. So we have this is the invoice. The customer that is that this invoice belongs to is customer number. So we have an ID, the invoice number. Okay, so would that be like the invoice ID, the invoice date, the total due on whatever date? Okay, details of what the invoice is about, I guess. All right, fine. The invoice. Okay, they follow an extremely simple life circle. They start out as open when issued to a customer, then they become closed when the customer pays. Invoices have two important dates: the invoice date. Okay, I guess when the guy paid, when it is issued, and the due date. Okay, when when they have to pay, or when they pay would be an important one, I guess, or not pay, I guess. So this makes sense. Due dates vary depending on the customer's payment terms. So date we issued the invoice, end of the month, terms would be due here, end of the month. Okay, net 30 terms would be due here, and net 60 would be due there. These due dates are also is it what is this squishy? If I read it right, they're also squishy when deciding if the invoices in when deciding if an invoice is late. We don't just go off the dates as written on the invoice. We factor in the customer's rating. If they're a good customer, we add a generous grace period to their due date. If not, they get charged fees much sooner. Last thing to know, invoice numbers are special and have to be handled by an external service or system, somebody else. We have to call them to get that. We have to make an external call. The invoice we make in our system aren't real. until the central billing service has allocated a number and delivered the invoice to the customer. Our service is just the middleman. This central billing service segues us into the hellscape in which we will implement this feature, the legacy system. So this is the legacy system. We have ours and it's making call to this system, this billing system, approval system. Right, cool. In modern software oriented fashion or service oriented fashion, information and functionality will be fragmented across often arbitrary feeling web services. We have to interact with all of these to complete our feature. So we have to interact with 1, 2, 3, 4, 5. 1, 2, 3, 4. And 5 is going to be ours. Fancy machine learning system that assigns a rating to each customer based on behavior: good, acceptable, or poor. Contract holds legal agreements like the customer's payment terms, billing, the invoice, internal, whatever this is. All right, cool. To keep things simplish, we'll ignore HTTP wrappers and failure modes. They'll return the relevant data and that's it. Assume all are blocking and synchronous. So you have this called rating. I have it already. We have interface. I don't know if I have this because, I don't know. Yeah, so we have some enums and you have a payment term. I think payment term is from contract service. Okay. Oh yeah, it says it. Approval, you have pending, approved, denied. And then you have billing API is going to be accepted or skipped, rejected, I guess. All right. I will type it up and actually, can I even get this done? I gotta go. Let's get it done. This and then we'll come back again. Are we done with the setup? Can we get to the rest of the book now? No, it gets worse. To show how data-oriented programming works in real life, we need all of the pre-existing stuff that makes programming hard. We need databases and entities and ORMs, and most terrifying of all, prior decision. Ugh. Catch you guys tomorrow, man. I gotta go work. Got to go work. Okay.